Hi, hello, and welcome to today's session. And in this session, we are discussing Bastion Host. And why we use Bastion Host basically is that you have a use case wherein you have resources in your private subnet which you want to access in order to configure or deploy your applications. And now, in your private subnet, you could have appliances like a database server, you have an application server, or whatever, but you need some kind of an access into these appliances in order to configure, maintain, and whatever can be the use case around it. But then the private subnet that you have, you don't have the routing via internet gateway to public traffic or the public network. So any external network, you don't have capability there that external networks could access any resources that you have within your private subnet, because when you configure a route table, you don't specify any internet gateway routing to your private subnets. And that's how it is meant to be, that it is private. It's running on private IP, all these resources, and it's not exposed to the outside world. Now, the challenge statement here is that in that case, how are you going to access these resources? Say, for example, if I'm talking about a use case wherein your architecture guidelines for your particular application development says that you need to have a couple of app servers deployed in a private subnet, and there where you are going to deploy your application. But as somebody who is managing the app deployment, you need to access these app servers. Say, if I'm talking about a Linux machine, you need to SSH into these Linux machines in order to configure the HTTP server and then further deploy the application, test the application, or whatever kind of activity you need to perform on these instances. And for that, you require SSH access into these appliances. But how are you going to access it? Because these are running on private IPs. So what is the best practice around accessing these appliances? And that is what we are trying to discover in this lesson. So that's where the Bastion host comes in. So the idea is that we will have an appliance in the public subnet, which will act as a springboard to log into these private resources, and it will act as a single point of entry, and hence like it helps in multiple ways, like controlling the access, security, and whatnot. So before moving forward and deep diving in further into the concepts, let's understand why we use Bastion host. So Bastion host basically, as the definition says, is a special purpose server that is used to securely access other servers or resources within a private network. So in case of AWS, this private network is a private subnet that you have as part of your VPC. So and apart from that, some other reasons why we use Bastion host is that it is a secure and a controlled way to access the servers or the resources that you have in your private subnet. So by using a Bastion host, you ensure that you are only allowing the authorized users to access your resources. So you can put in those control mechanisms. And secondly, because it acts as a single point of entry into your private network, so you get a better control and monitoring access on like who is trying to access your resource. So because since it acts as a single point of entry into multiple resources or multiple private resources that you launch in your private network, then it also provides you a simplification in or it helps you simplify the process of accessing the servers or resources that you have in your private network, because you don't need to deploy very complex setup like a VPN. And with a Bastion host, like in a very simple and a very secure way, you can quickly deploy it in order to gain access to your instances in the private subnet. Apart from that, because it acts as a single point of entry, so you could deploy all kind of monitoring and logging activity to monitor and keep a log of the access for these instances, and it helps you put in place all that mechanism that and all that access log, which can be helpful in the audit and compliance activities. So essentially, if we talk about overall, Bastion Host just not gives you a way to access the resources in private subnet. It also helps you in putting in your security mechanisms, your control, your compliance. So basically, it takes care of the entire um, cloud governance policies that are enforced from your organization, and your security best practices are all intact in place and enforced with a Bastion host. So in order to understand the working of a Bastion host, you do a hands-on session wherein the first thing that we'll have to do is that we'll have to create a private subnet in the default VPC, and we will have to create a custom route table and add the destination and target there in order to configure the traffic flow. Now, having said that, we will deploy a couple of EC2 instances that would be our app service that we need access to deploy our application or configure our HTTP servers. But this we wouldn't be able to do directly. We wouldn't be able to directly SSH because this is running on private IP, running in a private subnet. So here comes in the Bastion host that we'll have to deploy. So first we'll deploy EC2 instance in the public subnet under the same default VPC. And after deploying this EC2 instance, it will act as our Bastion host or our jump server. We will have to configure a security group and attach it to the Bastion host in order to allow the incoming SSH connection or the inbound SSH connection from the external network. Now, this client can be on an external network that can be my office network, or it could also be my home network. So I would whitelist only that CIDR block or that IP from where I am trying to access this EC2 instance, so that this SSH port is not open to the entire world on the World Wide Web. And that is a security best practice. So you should always restrict the SSH connectivity to only those CIDR blocks from where like you expect to connect into your EC2 instances. And this configuration we'll be doing in the source of our security group one where we'll be defining the CIDR block of my source or my client. Okay. Now, having said that, I have the setup ready. I'll test the SSH connectivity by using a Putty or any SSH client. I'll test out the connectivity. And from once I'm logged in by SSH into my Bastion host, from here I'll just ping these two private instances in order to just confirm the connectivity and the routing. The table is properly configured, and the traffic is properly getting routed internally. And that would be possible because all these three instances are running on the same private IP from the same CIDR block, which is the VPC primary CIDR block. So whether it is a subnet, public subnet, or private subnet, these two CIDR blocks are basically subset of the primary CIDR block of the VPC. So that means that all these devices that we launch, they are able to communicate over their private IPs internally with each other. So once we have established and verified that these are able I'm able to ping to these two servers from a Bastion host, I can initiate SSH connections into these two EC2 instances. But remember, the private key of these two instances wouldn't be available on the Bastion host. So how is the connectivity going to be possible? So one way, which is not the right practice, would be that I copy the private key of these instances into the Bastion host, and then I initiate the SSH connections into this to it, and then that would go successful. But again, please note that that is not the best practice, because if your Bastion host is compromised and somebody gets hold of the key, then he or she could easily get access to all the resources that you have in your private subnet that uses that same key. And generally, the practice is that there is a common same private key that is used for most of the instances that you have running out the same model. Like, for example, if you have 10 instances as part of an auto scaling group that you have running in your private subnet, they may have the same private key. And if that gets compromised, all your 10 EC2 instances are compromised. So it's never a good practice to actually copy the prior key onto the Bastion host or your jump server, and that's where the concept of uh, SSH forwarding agents comes in, which runs on your client machine from where you are trying to initiate the connection. So what you do is that you add your um, keys for these instances in the key chain of your forwarding agent, SSL forwarding agent, and then that key is automatically forwarded when it is trying to authenticate the connection into these two instances. So we'll see that in action once we work on it. So let's get started. Let me log into the console, and from there we'll see this in action. So now let's log into the AWS console, and before moving forward with the EC2 instances and launching the private instances, let's have a quick look at the VPC structure. So in the VPC dashboard, we can see that there is a default VPC which we are using, which comes in created along with the account. So under this VPC, now we get default subnets. So all these subnets are public subnet. We needed one private subnet, so I've already created this private subnet, and I have configured the route table for this private subnet, wherein you can see that in the routes only local routing is allowed, and there is no routing via the internet gateway, which means there is no outside network that is able to access any resources within this private subnet. Now, what we'll be doing is that we'll be using this private subnet to launch EC2 instances that will be acting as our app service, and which will be private instances to which we want to SSH from the Bastion host. So now moving to the EC2 console, you see here that the Bastion host I have already created, but let me show you the configuration here. So it is just a normal EC2 instance running Ubuntu, and for the security group, I have associated security group 1 with this EC2 instance. And if I open up the inbound rules, you can see here that for the inbound rule, SSH has been allowed over port 22 from a custom source, which is depicting a one IP address with a CIDR block. And this IP address belongs to the home network from where I'm trying to connect to this EC2 instance. So this is a public IP address given to my home network, internet network from my internet service provider. So you can also do that by just going in and just click on my IP, and it will associate it. Now, having said that, we are all set and done, and what we have to do now is we can test out the connectivity first, the SSH connectivity from my home network into, or my client on my home network into this Bastion host. And then we'll go about creating the EC2 instance in private subnet. So for this, what I require, I can just go on and click on connect, and then I can copy these parameters to connect to my EC2 instance. So now I will open up my client, my SSH client, and in my client I've already configured the jump server. I'll just initiate this connection, and we'll test out the SSH connectivity. And as you can see here, that that I am now logged into the Bastion host, and we can verify this with the private IP, which is reflecting here. And if I go back to my console, and I can see here that this is the private IP, which is also reflecting here. That means I'm logged into my Bastion host. Now, the next part of the exercise is to go in and create these two EC2 instances, which I have not created yet. So the private subnet is already created. Now I'll go in and launch a couple of EC2 instances in the private subnet. So let me go back to the console. I'll say launch instance. I'll say private one. I'll use a Ubuntu instance and P2 micro. I'll create a new key pair. I'll call it my app, or let me call it servers. And I'm going to use PEM file, create the key pairs, it's downloaded, and then in the networking, I need to edit this to select the private subnet. So this is the private subnet where I want to launch the instances. And what I would do is that in my security group, I just have security group 1 created. I'll go in and create security group 2 as depicted in the diagram. So let me show you. So we are talking about security group 2. And what we have to do is that in the inbound rule, we have to open the SSH port over port 22. And in the source, we are going to define security group 1 as a source. Now, if you are not sure about why I am doing this, this is a concept of security group referencing. If you are not aware about this, please go and watch my video on security groups where I have explained in detail with a hands-on lab around the concept of security group referencing. So we come here, we call this SG2, and in the description, I'll say open SSH from Bastion Host, which is SG1. Okay, so now in this SSH connections are already like defined. In the source, I'll say custom, and I would define the security group 1 as the source. That means, what it means is that any appliance that you are going to attach with security group 1 will be allowed to SSH into any appliance which you are attaching with security group 2. So that is the concept of security group uh, referencing. Now, what I want is I want two instances here. I mean, just for demo purpose, one would also have been okay, but just in case. So I'll launch these instances, and let's go back to the instances. One we can call it private to save. Now let's see. So we have the private IP addresses here for these two instances. These instances in the security, if you check, they are attached to security group 2. Now, what security group 2 is doing is that it is allowing SSH connection, but in the source, you see that this is the ID of the security group 1, which is attached to the Bastion host. Means Bastion host is the source here, which will be allowed to enter or to initiate traffic over port 22 into these instances in the private subnet. So let's go back to the EC2 dashboard, and we have these instances getting initialized, but let's check out if whether we are able to ping using this IP address. So we go back to the Bastion host and just let us see if ping is allowed. Okay, I think because we have only opened SSH connections, this may not be allowed here. Rather than opening up and testing this out, let us directly do one thing. Now, I am not doing the right thing right now. So what I'm going to do is that from here, what I want to do is I want to initiate a SSH connection into this IP address, which belongs to the EC2 instance, which is Tech Hub Private 1. But right now, if I initiate this SSH connectivity, I would need the private key on this location. On this location right now, if I do uh, less -L, you see that we don't have any key file here. So what I'm going to do is that I'm going to take the private key from my downloads folder. I'm going to drop it here. Um, and this will get uploaded to the Bastion host. And here we have the key with us now, and we just need to do a chmod 400 on this key, and then it is ready for use. So now from here we can initiate the SSH connection. Sorry, I need to copy the private IP once again, and sorry, I made a mistake in the command. And you can see here that I'm being asked to verify the fingerprint. I just say yes, and you could see here that I am able to log into the private EC2 instance. And that is because I have the key file uploaded here. But please remember, this is not a security best practice. Okay. So what I would do is that, because as I mentioned earlier, if this Bastion host gets compromised and somebody gets hold of this key, and then he will gain access to all the instances in your private subnet which is using this key. So this is never a good practice or a security best practice, and hence it's always advisable not to use this key or have any private keys uploaded here. So in that case, now what is the alternative? Alternative is to use a forwarding agents. So I'm on a Windows system right now, so I will show you how you can use the Putty forwarding agent, and I'm going to close. So before moving on to the Putty forwarding agent, first let me show you how we will do this with the client that I was currently using, which is the Xterm client. So I have deleted the uh, direct SSH connection to the Bastion host, and instead I am going to initiate a new connection. And here what happens is that the idea basically is in terms of forwarding is that as I mean key forwarding is that you connect to the Bastion host, and then when you are connecting to the Bastion host from your client, you are actually forwarding the key to this session. And from this session, because you initiate connection to your private instance, and in the session you have the key, so you don't need to actually deploy the key on the Bastion host. So it's in the session. From the session, it is picked and then it is authenticated to authenticate the SSH connection into your private instance. So you will never copy the key the to private 2 or private 1 instance into Bastion host. Rather than from your client, you are just forwarding the key in the session to the SSH connection that you established to your Bastion host. And again, from that session, the key is picked and then used to authenticate for SSH session into private 1 or private 2 EC2 instance. So let's see this in action with first the Xterm client. So what I will do is that first I need to go to network setting and SSH gateway jump host configuration it is asking for. So I am basically initiating the connection to the Bastion host here. So I will check my Bastion host here. I will take the private IP. Sorry, there it goes. How do I copy? Okay, let me cancel this one now. Okay, is this? Okay, I needed this. Now I'll go back to my client, click here, put the host name, username is 2, I use the SSH key for my um, Bastion host, which was this, and I click OK. Okay, it's just loading the key. So this is saved. Now we have to go to advanced setting. And now here, what I will do is I click on X11 forwarding. And what I have to do here is that I have to give the host name for the private instance where I want to connect to. So I will take say private 2 for now, copy the IP and the host username is 2. And we define the private key for the private instance, that is TechHub Absolute them. Click on open and just click on OK to save this. So now as soon as you click on save, you see that this connection is getting initiated, and you see that you are inside an EC2 instance that has private IP ending 254. And if I will go back, we see that this is the same IP. That means in this process, it just used the jump server and then established a connection into the private instance, and that is port forwarding in action using Xterm. Now I'll show you the same thing with Putty, because Putty is one of the widely used um, client to initiate SSH connections from your Windows environment. So let's open up Putty. So I'll just delete this for now so that I can show you the entire configuration as said again. So first thing that I need to configure here is the Bastion host. So I'll go back. I'll put the username @host, and then I'll go to SSH. Then I'll go to auth, expand auth, and you have to make sure that allow agent forwarding is enabled. Then go to credentials, and then go to browse, and then give the PPK file for your Bastion host. So the key file is loading. Okay, it's loaded now. Now what we need to do is that we can just save this file. Okay, and we can go back to session. We can call this jump server, save it, and load it, and then click on open, and we'll test connectivity to our Bastion host. So this is connecting to the Bastion host, and not yet it is connecting to the private EC2 instance. Okay, so for that we need to do something. So the idea is that when we connect to the Bastion host, the key should be forwarded to the session that we have established right now with the Bastion host. And for that, what we can do is that there is a utility called pagent that you can see here. Okay. Now, what you can do is you can import the key. So you can add the key. So here we can add the key for my private instances into this pagent. And what it will do is that every time that we are connecting to the instances, this key to the Bastion or the jump server, this key is being forwarded in the session. So just add it, close it, and I'll just exit this for now, and I'll reopen my Putty, connect to the jump server. Okay, so I'm connected to the Bastion host. In my Bastion host, let me do ls-l. On this location, I don't have any private key right now, but now I will show you that I am able to connect to my private EC2 instance, which is on host IP, private IP ending 254. So now if I just give SSH, see, I don't need to specify the key file with hyphen I. So I'll just give username at the rate host, that is u12 at the rate private IP, enter. And you see it is asking for accepting the fingerprint, and now you can see that I'm inside the private IP as depicted here 254. So I am inside of my private EC2 instance. And how did this happen? How didn't it ask for a key, a file? That is because with the P agent we had added the key file for this private instance, and when we established the connection to the Bastion host, this key file was forwarded in the session, and when we initiated this SSH connection, it was picked up from the session and authenticated. And that's the whole concept around SSH forwarding. Similarly, so with this, you can also configure the SSH forwarding on your Linux and Mac systems. You can configure this with a few commands from your console itself. And that's all for today's video. This was all around the best practices to manage your resources in the private subnet. And with the Bastion host, you get a single point entry to manage, monitor, control, secure your resources that is in your private instance. And you, with the SSH forwarding, you get an easy way to access your instances. So thanks for watching. If you find the video useful, please do stay tuned. Try to subscribe to the channel to keep yourself up to date with more interesting topic that would be coming up. Again, thanks a lot for watching. Thank you.